So again, fundamental theorem of algebra, whatever the degree of your polynomial is, that's going to be how many zeros you have. Zeros may be complex or real. Some of them might be repeated. And then the other big theorem that we're going to be using quite a bit today is this one. If you have complex zeros, they're guaranteed. This is for polynomials. If you have complex zeros, they're guaranteed to come in conjugate pairs. So, for example, if I tell you that 2 minus 7i is a zero for a particular polynomial, then you should be able to use that to predict another zero. What would your other zero be? 2 plus 7i. I'm sorry, it's frozen. Thank you. So if 2 minus 7i is a zero, then 2 plus 7i is also a zero. Has to be. Because complex zeros for a polynomial always come in conjugate pairs. So we're not going to be factoring the polynomials with complex zeros in this first assignment, although I'm going to have you do a couple more problems from 2.4 to continue your practice with that. We'll get to that in part 2, which we'll do on Monday next week. But today we want to just practice with looking at polynomials that are in factored form, turning them into standard form, and then also using this fact about complex zeros. So rather than making up examples, I'm gonna do a couple problems that are off the same page as your homework. So this is gonna be your homework assignment. So it's actually a relatively short assignment. I don't know what I was thinking. You guys have twice as long to work today. I should have given you twice as much work. Nice job. Well, I'll make it up to you on your next half day. So that's your assignment, right? And we're going to do some even numbered problems from the same thing. There's basically 3 sections of problems here. We're going to do 1 problem from each of those sections. So I'm not doing problems that are directly on your assignment, but they're the ones that are right next to the ones that you're going to do in your assignment. So you got some good examples to base your work off of. So if you've got your book and you'd like to look at the instructions for these, I'll put them up on the screen here in just a moment too, so we can see them. But that's the assignment. Page 225. I don't know if this is the right page number, but you know, if I say page 225 and you don't see a problem 53, to just flip a couple pages until you do see one, right? Okay. These are just like what we practiced in class on Tuesday and last Friday. Those are those ones these are the ones that take quite a bit of work. Okay, these 2 problems will take you in total probably about the same amount of time as these 8. This is half your assignment. This is the other half, basically. Time-wise, that's what I would anticipate. All right, so we're going to just jump right to it here. We'll start with number 2. So if you happen to have your book and you want to turn it to page 234, I'll go ahead and put it up here. So the instructions say write the polynomial in standard form. You know what I mean by standard form, right? With no parentheses. Yeah, so no parentheses, and basically we got to multiply it out. And identify the zeros of the function and the x-intercept of its graph. So zeros and x-intercept, we know the relationship there. So number 2 gives us a polynomial that's in factored form, not standard form. So we'll have to do some work to put it into standard form. And the factors they're giving us are x plus 2 and x minus root 3 times I and x. And I could predict what this last one is going to be. They told it to us, but if x minus root 3i is a factor, then the conjugate must also be a factor, x plus root 3i. And this time around, they actually gave that to us. But So let's write out our zeros. Looks like we've got one real zero. X plus 2 is going to give us a 0 of 2. Or negative 2. Almost made a mistake there. I guess I did make a mistake, but I caught it. From this factor, if I set that equal to 0 and solve, I'm going to get positive root 3i. And from this one, if I set that equal to 0 and solve, I would get negative root 3i. So there's my 3 zeros. Looks like they're all multiplicity 1. If I have 3 zeros all multiplicity 1, fundamental theorem of algebra says what's my degree going to be for this polynomial? 3 zeros should be a third degree polynomial. The number of zeros should match the degree of the polynomial. We're going to multiply it out, so we should see an x cubed for our leading term. They asked us to do x-intercepts also, which is nice because these come from the zeros, but we have to modify that a little bit. The zeros become x-intercepts, but only if what? They don't have to be rational, but you're on the right track if they're real. So there's actually only going to be one x-intercept for this graph. These two imaginary zeros are not going to contribute x-intercepts. So my only x-intercept is going to be a negative 2, 0. So imaginary zeros will not show up on your as x-intercepts.
So if the question has only imaginary for x-intercept, we write
none. Yeah. Yeah, that's a great question. If there are only imaginary zeros, then there would be no x-intercepts. All right, here comes the work. We need to multiply this out. Now, we learned a nice little trick. Do you guys remember the little trick that we learned for multiplying conjugates? We learned this on Tuesday. That whole thing that a plus bi times a minus bi is equal to a squared plus b squared. So let's use it. So I'm going to go ahead and rewrite f of x equals, I'm going to leave the x plus 2 alone. I'm going to multiply these two factors together using that. So it looks like a in this case is x. So a squared would just be x squared. Plus, and then what am I going to get if I square root 3i? Root 3i squared would give me what? Square the root 3, we're going to get 3. Square the I, we're going to get negative 1. So negative 3? Yeah, so instead of plus, I should write minus 3. Now, if you want to sit there and do your FOIL for that, you're welcome to do it, but the shortcut is kind of nice. Oops, hang on. Hang on. I think I made a mistake here. You guys think I made a mistake? I would not include the I, right? Because it's b and then I. So my b is root 3. My b is root 3. So there's no negative. So it is a plus 3. My bad. That's 2 today. Let's see if we can get up to 5. 5 mistakes. You guys keep catching them. Thank you. And that should be x squared plus 3. So it's a squared plus b. The a and the b do not have the i's. The b doesn't have the I in it. That was my mistake. I included the I along with the root 3. So it's x squared plus 3. Cool. We okay with that? And again, if you wanted to work it out with FOIL, you could. It would just be extra steps. All right. Cool. We can do this then. Let's multiply that out. Use your favorite method to multiply two binomials. If you like the FOIL, go with the FOIL. If you like the box thing, go with the box. You know what I mean by the box, right? I think I'm going to go box for this one. 6 to the third. X squared So in order by degree. All right, so that's our standard form. When they asked us to write it in standard form, that's what they're asking us to do. Let me double check and make sure we hit all the parts of the instructions here. It said write the polynomial in standard form. Check. Identify the zeros, we have 3 of them, plus you, and find the x-intercepts of the graph. We only have one x-intercept because we only have one real zero. So I think we're good to go. Any questions on number 2? All right, let's move on. Next up, we got number 10. Skipping ahead to number 10. So let me show you the instructions here, and then we'll write down the information. So in this section of problems, they're going to give us some zeros. It says write a polynomial function of minimum degree. What do you think they mean by that minimum degree? What do you think? Lowest degree possible. We're not going to do what? We're not going to add multiplicities unless they tell us that we have to. They don't say anything about multiplicity. So these are all going to be multiplicity 1. Basically, they're telling us here, just keep them all multiplicity 1. So they're giving us of minimum degree in standard form with the real coefficients. Okay, so standard form with real coefficients, that's basically what we just did right here. So we might have to multiply some stuff out. Whose zeros include those listed. So be careful, they didn't say these were all the zeros, they said that the zeros include these. So we're going to do number 10. And what they give us in the problem is a list of zeros. They tell us that the zeros include -1 and 2 and 1 minus I. We said minimum degree, so we don't want to go adding additional zeros unless we have to. Do we have to add additional zeros? We do, because we've got a complex zero here. And we know that complex zeros have to come in pairs. We have to have complex conjugate pairs. So we need to include another one. They didn't tell us that this one was there, but we know that it has to be there because that's the rule. If I've got one complex zero, it's got to have a buddy, which would be its complex conjugate, which would be 1 plus I. And we're going to write this in standard form. I think we're probably going to have to start in factored form first and then multiply it out. So f of x equals, let's write some factors here. We should have 4 factors because we have 4 zeros. X plus 1, x minus 2. All right, it's going to be x minus this. Make sure that negative goes onto both things. So that would give you x minus 1 plus I. And here, x minus 1 minus I. All right, and then the joy of this problem is that now we get to multiply all that stuff. Yeah, it's gonna be awesome. So check it out. We could use our little shortcut, the a plus bi thing. A plus bi, a minus bi. We've kind of got that going on with this. So remember, it's a squared plus b squared. So if I'm looking at these two factors, what would my a be? What's the stuff in this factor that is not attached to the I? X minus 1 is kind of my A here. And what is my B? My B is, no, that's the mistake I made a minute ago. Remember, I included the I in my B? B is just the coefficient in front of the I. What is the coefficient in front of the I? 1. So if I'm going to use my shortcut here, my A is x minus 1 and my B is 1. So let's off to the side here figure out what x minus 1 squared is. Spoiler alert, it's not x squared plus 1. It's x squared minus 2x plus 1. Thank you. So I can just do that. That's my a squared. And then my b squared is 1. So it's going to be x squared minus 2x plus 1. That's my a squared. And then my b squared is 1 squared, which would be 1. I'm going to pause for a second. Look over that, especially that x squared minus 2x plus 1 piece of it. Are you guys okay with where that minus 2x part came from? If I were to multiply out x minus 1 squared, unfortunately, we cannot distribute an exponent into parentheses if there's addition or subtraction. So I would actually have to do x minus 1 times x minus 1. And if you went through the process of FOILing that out, that's what you're going to get. You're going to end up with a negative x and another negative x. That's where the negative 2x comes from. So I'm going to say altogether that's x squared minus 2x plus 2. Right. And we've got x plus 1 and x minus 2. Now we've got to think about what we're going to multiply next. What do you guys think? Do you want to do the two binomials together, or should we do one of the binomials times a trinomial next? Does anybody have a preference? You want to do the two binomials together first? All right, let's do these. We'll leave the x squared minus 2x plus 2. You know what? Actually, I asked you what you wanted to do, but I'm going to go back on that. I'm going to do what I wanted to. I think it's actually going to be more efficient if we multiply the like one of these into this. So I'm actually going to do it the other way. Why don't you do it that way, and we can compare and see who ends up doing more work. I'm going to leave the x plus 1, and I'll multiply these two together. Now, when I'm doing a binomial times a trinomial, I am definitely setting it up with a rectangle. Otherwise, I'll lose stuff. Just double checking my signage here. Good. Do a little combining like terms as we bring this over. It's only 1x cubed. Got a couple x squareds here. And I got a couple x's. And a minus 4. It's a little messy here. All right, now I got to multiply the x plus 1 into it. This is just kind of tedious. It's not terribly difficult. It's just kind of tedious. So I had a student a couple of years ago. We were doing this, and they asked. That was a really great question. Like, when we divide by a binomial, we've got this thing called synthetic division that makes it really easy. They're like, is there such a thing called synthetic multiplication? And there is actually, he looked it up and figured it out. I don't remember how it works. It looks kind of like synthetic division, but it's basically the same idea. You would use these coefficients, you put -1 in the box, and you go through, and it spits out what you would get for multiplying them instead of dividing them. So if you're interested, look that up. I'm not gonna show you because I don't know how to do it. If you look it up and figure it out, teach me, please. Combining like terms, and we're almost there. Almost there. Oops. Slow down. Does any of this work look familiar to any of you? Where have you seen this? Well, just this idea of multiplying a whole bunch of factors together to come up with a polynomial. Has anybody looked over the poly project? I know a couple of you have. This is basically what you're doing in the first half of the poly project. I'm gonna give you a whole bunch of factors and you got to multiply it out. It's big, it's long, it's messy. It's not hard, right? If you go slow and you don't make mistakes, then it goes quicker. It takes a long time if you find yourself making mistakes. You got to go backtrack and do a bunch of work. We only multiplied out four factors here. I think in the poly project you've got 5 or 6, and one of them is a trinomial. So it is. I mean, I'm giving you 50 points, right? It's 50 test points for doing it. So it's not going to be something you're going to sit down and do in 10 minutes. But and then the first half of it will be this, and then in the second half you basically take it apart again. You do that work that we practiced last class, where you graph it, you factor things out, pull all the factors out of it. You end up back where you started from. I think it's a great project. I got a couple people that are almost done with it already. So that's my plug for poly project today. Email me if you want a version number. You can't just do it on your own because there's 50 different versions, and I have to assign it to you. So read the information and email me if you're interested. All right, one more. You guys are doing awesome. How are we doing on time? Oh, we're great. 10:08 is when this class ends, so we're in good shape. Last but not least, number 16. So this is the third section of problems you're going to do. Let's have a look at our instructions here for 16. All right, so write a polynomial function of minimum degree in standard form with real coefficients. Basically, so far this looks exactly like what they said. The zeros in their multiplicity are those listed. Oh, okay. So this is the same thing we just did, except now they're giving us multiplicities for some of our zeros. So the same exact thing, it's just new multiplicities we're going to add in here. So what did they tell us? In 16, we've got some zeros. -1 is a 0, and that's multiplicity 2. And -2 minus I is a 0, and that's multiplicity of 1. And they said minimum degree, so we're not going to add any more zeros in unless we absolutely have to. Do we absolutely have to this time? Yes, we have a complex zero. Those have to come in pairs. I don't see a complex conjugate for this in here yet. So we're going to have to put our own in. So -2 minus I, the conjugate would be -2 plus I. Remember, it's only the imaginary part that switches signs. All right, so let's write our function. We'll start with factored form. So this first factor is going to be multiplicity 2, so it's going to be squared. So that's x plus 1 squared. And then we've got 2 more factors, x. Okay, so it's minus this, so the sign's got to flip. So it'll be x plus 2 plus I. Sign's got to flip here again, so x plus 2 minus I. Minus I. Just my minus. Can we do our little shortcut with the conjugates again? Or do you want to do it the long way this time? Shortcut? Shortcut. Let's go shortcut. If I'm looking at these two things, the thing that's in common, the A part would be the x plus 2. And the B part is the coefficient on the imaginary, which is 1. So B is 1. And A is x plus 2. So we got to figure out what's A squared plus B squared. So I am going to need to figure out what x plus 2 squared is. Do you guys know the shortcut for squaring a binomial? Some of you yes, some of you no. This is one of those things that'll save you a ton of time if you can learn this. There sure is. A plus B squared is equal to. So it's got an A squared and it's got a B squared in it, but it's got a middle term, which is multiply these things together and double it. It's that middle term that everybody always forgets. They want to just square the x and square the 2, but they don't multiply them together and double. So when I do this, I square the first thing, square the last thing, and then x times 2 and double it. So that would be 4x. That's your middle term. And then b is 1, so we're going to do plus 1 on top of it, right? A squared plus b squared would be that. So when we're doing our shortcut, this is going to end up being x squared plus 4x plus 5. This right here, this trick for squaring a binomial, oh my gosh, you want to know that. You're going to want to know that for next year. You're going to have binomials that are going to be like 2 plus the sine of x. And you want to be able to say, oh, well, that's just 4 in the front, that's 2 squared, and sine squared x in the back, that's sine squared. And then multiply them together, 2 times sine x and double it, so that'd be 4 sine x in the middle. You want to be able to do that because it's going to save you lots and lots of headaches. In fact, why don't we practice it right here? It looks like a great opportunity, huh? We are squaring a binomial. So use the shortcut. Square the first thing. Square the last thing. Multiply them together and double it. X times 1 doubled would be 2x. Awesome. Now all we have to do is multiply those two trinomials. Yeah, I'm going a long table / box for this. Hmm. I like using the table or the box because you get those diagonals, those like terms line up along the diagonals there, so it's pretty easy to combine them up. All right, those are our 3 examples. By the way, well, I guess you guys have odd numbered problems, right? So you know where to check your answers. But if I ever did assign an even numbered problem, like how could I right now use my computer to check whether this is the right answer? What did we learn last class? Wolfram alpha. You guys learned about adult photo math last class, remember? So don't forget that's out there. You could either type this in, or you could type your answer in and see if it factored into this. If you type this in, it would multiply it out, and it would give you this at some point, among like 50 other things. That the only trouble with Wolfram alpha is you type something in, it's going to do all kinds of stuff to it. You have to know where to look to find the thing you're looking for. But we know we'd be looking for a polynomial. It'd probably be pretty easy to spot. All right, you guys got time now to start on that homework assignment. Does anybody have any questions over our last assignment? Were there any? I'll handle questions from page, what was it, 50 something, 60 something. P6. Anything from page 57 that we can go over? You guys feel confident on those complex numbers? Rationalizing, all that good stuff. Any other questions? I am not one to waste time.